Hello, welcome to ATI 4640. In this session, we will continue discussing the strategic importance of the layout decision. We will discuss the process-oriented layout, the work cells or the facility focused or focused facilities, and product-oriented layout. Some examples will be provided to explain the differences. In the process-oriented layout, machines and equipment will be arranged in a certain order to accommodate the sequence of processes used to produce certain items. It's also called the job shop layout and should be flexible to handle a wide variety of products or services. Scheduling for such a layout could be difficult. In addition, the setup for the machines in a certain order, material handling and labor costs could be high. This is an example of a process-oriented layout in the Arnold Palmer Hospital. Look at the different processes and the need to lay out the hospital units in a way to facilitate patient care. Although in some cases the sequence might differ, but at least the patient will not be transported very far just to go to a blood test or to X-ray. The layout design was made to facilitate patient care and patient services. In a process-oriented layout, work centers are arranged in a way to minimize the costs of material handling. And this is what we said before. Material handling cost is the most important part of the layout of the facility. The basic cost elements in such a layout are the number of loads or people moving between centers and the distance between those centers. This is what determines the cost and the material handling with or within or between these departments. The objective of the layout will be to minimize the cost, which will equal the summation of the number of loads moved between two departments multiplied by the cost of that move. To understand the method of arranging the different departments, let's look at the following example. We need to arrange 6 departments in a factory to minimize the material handling costs. Each department is 20 by 20 feet and the building is 60 by 40 feet long and wide or width. The cost of moving one load between adjacent departments is $1, while the cost of moving loads between non-adjacent departments is $2. To design the process layout, we need to go through the following steps. First, we need to construct from 2 matrix so we know where the loads are going from and to which department. Then we need to determine the space requirements for each department. Then we develop an initial schematic diagram. Then we determine the cost of this layout and we try to improve the layout, then prepare a detailed plan. This matrix shows the number of loads that will be moved between the different departments. The initial layout is shown in this figure utilizing the building space as stated in the example. Is this the best layout? Could the layout be more efficient with lower cost? So we're going to calculate the handling cost based on the number of loads moved between the departments and see if that design can be changed to be more efficient and to lower the cost. This graph represents the interdepartmental flow showing the number of loads that will be moved between between the departments. Remember that the cost of moving one load between adjacent departments is $1 while the cost of moving a load between non-adjacent departments is $2. Based on the design and the current number of loads moved between the different departments, we can calculate the cost as follows. Using the formula, the cost will equal between 1 and 2. We are moving 50 loads, and since they are adjacent to each other, then it will be a dollar per load. Dollar times 50, that will be $50 total cost between 1 and 2. If you look at 1 and 3, the number of loads will be 100. Since it's 100 and they are not adjacent to each other, then the cost per load is $2. 2 times 100, that's $200. And we keep on going with the other loads and the movement between the different departments based on the matrix that we developed. And by summing all these costs together, we will get $570. Let's rearrange the building layout to make the department with higher load movement beside each other. So we will recalculate based on the design where we moved assembly from this position, this location, to this location. And now we can see that 1 and 3 are adjacent to each other, 1 and 2 still adjacent to each other, and we made also 1 and 6 adjacent to each other. Using the same formula, the cost formula that we used before, we can recalculate the cost using the new arrangement, and the results will be, or the total cost will be $480, and that's lower than the initial design handling cost. So the total saving is $90, which means that I did the rearrangement and reduced the cost. The new arrangement, if you look back at the new arrangement, now since I'm moving 100 units between assembly and machining, you can see that having them adjacent to each other made it more efficient instead of traveling more distance just to get the 100 units or loads between these two departments. And still I kept the movement of the 50 between 1 and 2 the same. So I did not change that, but I did change the assembly with machining and the assembly with testing. And again, we saved $90 by just doing this one move. So moving the assembly department to be adjacent to the machine shop, adjacent to testing, and still adjacent to painting department reduced the handling cost and increased efficiency. With larger loads amounts and more complicated environments, the graphical approach that we just used will be tedious, and maybe it will take times, days or weeks just to figure out the most efficient layout design. Keep changing the departments with if we have a large number of departments, then that will not work. So for more complex and bigger organizations, computer programs and software packages can be used to minimize cost and increase efficiency, such as ProPlanner. They have the PLM software, which is used to plan layout or draw the layout design. Some of the methods that will be used to solve such problems we will be using like flowcharts, the multi-story capability, the storage and container placement, the material volumes, the time and cost analysis. So with those problems, we have other methods to do or to solve or to use to solve the problem. The ProPlanner or PLM, ProPlanner is the name of the company, and they have PLM for manufacturing that has predefined workflows and data models optimized for assembly planning and flow path calculations. It will assist in a quick and effective deployment with guaranteed results. It guarantees material flow diagrams. It calculates the material handling distance, time, and cost. It generates color-coded flow lines, and it helps identify excessive material handling. This slide shows a screenshot of the software with the color-coded material flow and the layout design. New emerging technologies and software packages are used to assist in layout designs, some of which are three-dimensional, like visualization software that will allow managers to view possible layouts and assess processes, material handling, efficiency, and even safety issues just by using the goggles and the virtualization tool. The focused facilities strategy is appropriate if the company has a family of similar products with reasonably stable demand. These facilities are designed to meet the needs of the customer by matching facilities to customer requirements and demand. This type of design reduces waste in capacity and in resources. This process requires a takt time. The takt time is the total work time available divided by the number of units required to satisfy customer demand. Basically, we are trying to calculate the pace of the production to meet customer demand. For example, if there are 7.5 hours working hours available per day and daily demand of 600 units, then the takt time will equal 7.5 times 60 minutes divided by 600, which will equal to 0.75 minutes or 45 seconds. That means that every 45 seconds I have to have a unit produced or out from that production line. So the takt time becomes like the drumbeat, the pulse of the focused facility to which all facets of the organization march. So it's just the beat, the drum beat for the company. Examples of focused facilities are work cells. It could be focused work, which is a little larger than the work cell, and then the focused factory, which is also larger than the work centers. So basically we have work cells, work centers, and the whole factory or focused factory. The focused work cells are the smallest of the three types. It reorganizes people and machines into groups to focus on a single product or product groups. In this design, group technology identifies products that has similar characteristics for a particular cell. Volume must justify the cells, and cells can be reconfigured as designed or volume changed. I need to have many items that will go or will be processed into that cell. Otherwise, I will not be able to justify the cost for the equipment, the tools, and the people who will work in that cell. So most likely I will have a group of items that will go through that cell, and they will have almost the same characteristics or similar characteristics, so we can process them with the same way. And that's why we have like a work cell just for that, or focused on that job or that product. As part of the requirements of work cell, the company need to identify the families of products. We need to know what are the groups that we have and how they are related to each other. Then the company should include a high level of training, flexibility, and empowerment for employees, because they will know exactly what they're doing in each work cell. It's just trained, or they are trained just to do that job in that work cell. The work cell should be self-contained with its own equipment and resources. The people who work in that work cell stay or still work in that cell most of the time in that work cell. And then a testing and error proofing should be added at each station in the cell to reduce failures and to reduce errors. Work cell can reduce work in process inventory. Actually, it will take less floor space than other designs, and that's why most of the companies love to do it in work cells, to group their products and do them in work cells. It reduces raw material and finished goods inventories. It reduces direct labor cost, and then it increases the sense of employee participation. It increases equipment and machinery utilization, and it reduces investment in machinery and equipment. This is an example on improving layout using work cells. In the current layout, workers in small closed area cannot increase output without a third worker and a third set of equipment. In the improved layout, cross-trained workers can assist each other, may be able to add a third worker or a third person as additional output if needed or is needed. Another example, working in straight line where it's hard to balance tasks because work may not be divided evenly, and we might see that someone is being exposed to more pressure than other people in that straight line. An improved design will be to convert the workspace into U-shape cell where workers have better access. So from 4 cross-trained workers, we reduce that number into 3, and the space was enhanced and the communication were enhanced too. So in this space, they could communicate with each other, they could take over and help each other, they could assist each other, and it will be more efficient to do it this way rather than one long line or straight line. The other two types of focus facilities are the focused work center and the focus factory, as we said. So the focus work center can identify a large family of similar products that have a large and stable demand. So we are addressing a large work center that will be just specified for this family of products. And it moves production from a general purpose process-oriented facility to a large work cell. The focused factory is a focused work cell in a separate facility. It may be focused by product line, layout, quality, new product introduction, flexibility, or other equipment. A focused work center is a permanent product-oriented arrangement of machines and personnel in what is ordinarily a process-oriented facility. A focus factory is a permanent facility to produce a product or component in a product-oriented facility. Many focused factories currently being built were originally part of the process-oriented facility. In the repetitive and product-oriented layout, the strategy is to arrange the equipment or machines around the product or families of similar high-volume, low-variety products. In this case, the product demand should be stable enough to justify the high investment in the specialized equipment and the standardized approach. This layout strategy can also be used or if the suppliers of raw materials and components are adequate and of uniform quality. As an example of product-oriented layouts, the fabrication line and the assembly line shows how the uh, those layouts or these designs are more of product-oriented. The fabrication line builds components on series of machines, and it's machine-based, and it requires mechanical or engineering changes to balance. The assembly line put fabricated parts together at a series of workstations paced by work tasks and balanced by moving tasks. Both types of lines must be balanced so that the time to perform the work at each station is the same. These types of layout has advantages and disadvantages. The advantages are the low variable cost per unit, as we said, the low material handling costs, the reduced work in process inventories, easier training and supervision, and rapid throughput. While the disadvantages are the high volume is required. If I don't have high volume, then it's not going to work. The work stoppage at any point ties up the whole operation. If I stopped in at a certain place, that will tie the whole operation. And lack of flexibility in product or production rates. This slide shows McDonald's layout, which is designed around the different products in the menu, the sandwiches that's in the menu, or whatever they offer in the menu. The layout being arranged in a way to grant the goal of achieving the minimum time assembly or assembling a sandwich. In the product-oriented layout, and especially in the assembly line, it's very important to maintain the balance between the machines or personnel while meeting a required output. The balance between starts with the predecessors relationship, where we need to determine the cycle time, then calculate theoretical minimum number of workstations, then balance the line by assigning specific tasks to workstations. The following example explains how to balance an assembly line. Looking at the different tasks, their duration and the predecessors, we can see that the total time for all activities is 65 minutes, and that activity B and E cannot start before finishing activity A. Then we start calculating the cycle time for each unit, which will equal the production time available per day divided by the units required per day. If the working hours are determined to be 8 hours per day, that's a 480 minutes, and the required units is given as 40. Dividing 480 by 40 will result 12 minutes as time required to produce each unit, and this is what's called the cycle time. Dividing the total time of activities by the cycle time, we will get the number of stations required to produce the daily required amount, which will be in this case 5.42, or we can round it up to 6 stations. The heuristics or heuristic that we will be used in this is that the most following tasks. So from the available tasks, we choose the task with the largest number of following tasks, and that's the one, the layout heuristic that we are going to use. This figure shows the layout for the different stations based on the assembly line balanced method. So we found, or we can identify 6 stations, and each station will have its own group of tasks or one task as needed. To calculate the efficiency, we divide the task's total time by the actual number of workstations multiplied by the largest cycle time. In this case, we divide 65 divided by 6 times 12, which will equal to 90.3% efficiency, which is very good. That will be all for this session. If you have any questions, please let me know. Thank you and have a great day.